Hello everyone, welcome to the channel Code Like Him. Guys, if you find this video helpful, please like this video and subscribe to our channel. Now let's see today's problem. Equal sum grid partition 1. You are given m cross n matrix grid of positive integers. Your task is to determine if it is possible to make either one horizontal or one vertical cut on the grid such that each of the two resultant sections formed by the cut is non-empty. We need to do one horizontal cut or one vertical cut in such a way that the two resulting sections after one cut we will have two sections, and the two sections should not be empty non-empty, and the sum of the elements in both the sections are equal. So if we make a cut here, we will see 1 plus 4 5 and 2 plus 3 equals to 5. So this first section and this section have sum equals to both the sums are equal, so it is possible to make a cut. So we will return true, otherwise we will return false. So this is a simple problem. What we are going to do is we're going to have two vectors or two arrays, what we call, and we will having the sum of every row and every column in that vector. For example, we will be having the vector rows of n length because there will be n rows, and column vectors calls of m length because there will be m columns. And for every row we will be storing the sum of every row. For example, the first row will have sum 5, the second row will have sum 5, so we will be storing the first element of the rows column will be 5, and second element for the rows column will be 5. So and for the columns we will be storing the 3, 1 plus 2 3, and 4 plus 3 7 in the col section, in the cols vector. And then what we are going to do, we will be just totaling rows total and columns total. For example, for rows we will be having total like 1 plus 4, the 5 plus 5 10, and for columns this 3 plus 7 10, something like that cost total. That's And the rows we will be filling like the current element plus the previous row, because we want in the end we want the row the sum of every element in that particular row. And this is for the column, because first we will have 1, then we will have 1 plus 2 3, something like that. And we will be now having this rows total and columns total. We will check if the rows total is not equals to modulo 2 is not equals to 0, it means there's an odd number that and then if it is odd number, we cannot draw a line which will divide them equally. So we will return false. Then the required total for every for the first half will be the rows total divided by 2. That's how the required total will be, or the total sum will be the total sum of all the cells in that particular in the matrix divided by 2. That's we require for our first half. Now we will be iterating over the rows total one by one. So current total will be rows of I plus the current total will be plus equals to rows of I. And if the current total is equal to required total, it means we have find a particular line. In the first we will be having required total equals to 10 divided by 2 equals to 5, and the first row after adding first row we will get 5. So the required total equal to current total, we will return true in this example. If the current total is greater than required total, it means we have reached the point where cutting through making a horizontal line is not possible to divide the matrix into two equal halves. Then we will try to make a vertical line and then dividing the matrix into two halves. Similar approach here, we will be having columns current total 0, we will be adding columns of j, and if the current total is equal to required total, we will return true. Otherwise, if it is greater, we will return false in the end. So the time complexity will be big O of m cross n because we are iterating over the grid, and space complexity will be big O of n because big O of m and m plus n, because we are using the rows and columns for sorting the corresponding rows sum and the column sum for each rows and column respectively. So guys, if you find this video helpful, please like this video and subscribe to the channel. Thank you.